Okay, so for today, we'll discuss about the rational function. Okay, and then later on, we'll also discuss the inverse function. Okay, so now what are our learning targets for this lesson? Number one, differentiate rational equation, rational inequality, and rational function. Then number two, determine the solution set of rational equation and rational inequality. And aside from that, actually, we'll also discuss some application of rational equation. Then number three, determine intercepts, zeros, asymptotes of rational functions. Number four, find the domain and range of a rational function. Then number five, graph the rational function. Okay, so first let's define formally rational expression, equation, inequality, and a function. So a rational expression is an expression that can be written as a ratio of two polynomials. It can be described as a function where either the numerator and denominator or both have a variable on it. Okay, so since it's a ratio of two polynomials, always remember the requirements and the limitations and our rules when it comes to the polynomials. Okay, polynomial expression for the numerator and denominator. Okay, so some examples here are 1 over x squared, x plus 6 over x plus 7, x squared minus x plus 7 plus 8 all over x plus square root of 7. Okay, and then last one, x squared plus 5x minus 6. So as you can see here, it's a polynomial expression, and we can express this as a ratio of two polynomials, wherein the denominator is 1. And then rational equation, it's an equation involving rational expressions. Rational inequality, an inequality involving rational expressions. Uh, for instance, we have here for the equation 2 over x minus 3 over 2x, and then 2 over x plus 1 minus 2x plus 1 over 3x equals 1/4. Then 5 over 2x minus 8 is equal to 7x over 2x minus 1. And then for the inequality, of course, we use inequality symbols here. Okay, so it's a rational expression with inequality symbols. Okay, so for the equation, of course, we use the equal sign. Then now, let's proceed in solving rational equation. So as we solve rational equation, we'll use the Cram method. Okay, so what about the Cram method? So letter C, we clear all fractions by multiplying both sides of the equation by the LCD of the terms. Then R, remove all grouping symbols if there is any. A, add or subtract similar terms. M, multiply or divide both sides by numerical coefficient variable, leaving only the variable on the left side of the equation with the coefficient equal to 1. Then, check the result and determine if it is an extraneous solution or not. For instance, we have here x plus 2 over x plus 4 is equal to x minus 2 over x plus 2. Okay, so if we apply the Cram method, so first we need to clear our fractions here by identifying the LCD. Okay, in this case, we have the LCD of x plus 4 and x plus 2. Okay, so we multiply both sides by x plus 4 times x plus 2. Okay, so simplifying this, we'll have on the left hand side, quantity x plus 2 times quantity x plus 2 or x plus 2 squared is equal to, on the right hand side, quantity x plus 4 times quantity x minus 2. Okay, so as you can see here, we don't have fractions, but we need to simplify this. Okay, we need to remove the grouping symbols. So we can use the FOIL method here. So simplifying this, we'll have x squared plus 2x plus 2x plus 4 is equal to x squared minus 2x plus 4x minus 8. Okay, and then we need to combine like terms here. So we have here x squared minus x squared plus 2x plus 2x plus 2x minus 4x is equal to negative 8 minus 4. Then simplifying this, on the left hand side, it will be 2x, and then for the right hand side, that's negative 12. Simplifying this, we divide both sides by 2. The answer is negative 6. Okay, so you can check the answer by substituting it to our equation. Okay, but here in our example number 1, x equals negative 6 is the solution for this equation. Another example, x minus 4 over negative 2 minus 4x plus 5 over 2x plus 3 is equal to 0. So again, we need to identify the LCD here. In this case, we have negative 2 times the quantity of 2x plus 3. Okay, to eliminate the fractions. So simplifying this, we'll have on the first term of the left hand side, we have x minus 4 times the quantity of 2x plus 3 minus the second one, which is 4x plus 5 times the quantity of negative 2 is equal to 0. Okay, then again we apply the FOIL method and distributive property. So we'll have here 2x squared minus 8x plus 3x minus 12 minus the quantity of negative 8x minus 10 is equal to 0. Then again, we need to remove the grouping symbols and we need to combine like terms. So in this case, we distribute that negative sign, so we'll have 8 plus 8x plus 10. Okay, and then again combining the like terms, we'll obtain 2x squared plus 3x minus 2 is equal to 0. Okay, so we have here a quadratic equation. Okay, let's factor this. And the factors are quantity 2x minus 1 times the quantity of x plus 2 is equal to 0. Then find the value of x. So first, for 2x minus 1 is equal to 0, that's 1 half. And then for x plus 2, that equal to 0, that is x equals negative 2. Okay? So if you substitute negative 2 and 1 half to the equation, it will satisfy. So we can say that they are both solution for this equation. Next one, another equation here, x over x plus 2 minus 1 over x minus 2 is equal to 8 over x squared minus 4. Okay, in this case, again, we need to identify the LCD. So as we all know, x squared minus 4 is difference of two squares, and the factors are quantity x plus 2 times the quantity of x minus 2. Okay, so in this case, we can say that the LCD for this equation is x squared minus 4. Or you can simplify that as quantity x plus 2 times the quantity of x minus 2. Okay, then we multiply it both sides. Okay, for the left hand side, we'll obtain x times the quantity of x minus 2 minus 1 times the quantity of x plus 2 is equal to 8. Okay, so on the right hand side, x squared minus 4 will be eliminated because that will become 1. Okay, so that's equal to 8. Then again, distributive property. So we'll obtain here x squared minus 2x minus x minus 2 is equal to 8. Combining like terms, we'll obtain x squared minus 3x minus 10 is equal to 0. So again, quadratic equation, let's factor. So in this case, we'll obtain x minus 5 and another factor, x plus 2. Then finding the values of x is equal to 5 and x is equal to negative 2. Okay? But in this case, let's check both the values of x here if this will satisfy our equation. First, let's have if x is equal to 5, if we substitute that, we'll obtain 8 over 21 is equal to 8 over 21. So that's a solution. Okay? However, if we substitute negative 2, So as you can see here, the first term in the left hand side, if we substitute -2, we'll have here an undefined. Okay, -2 over 0. So in this case, it is not part of the solution. Okay, and it is extraneous. We call that as extraneous. Okay, therefore, the only solution for this equation is x equals 5. Last one, we have here quantity x plus 1 over x squared plus 4 times the quantity of x plus 1 over x plus 3 is equal to 0. Okay, so first here, you can simplify this and you solve for the value of x. But let's try to observe. As you can see here, uh, the factor inside x plus 1 over x, we can represent it by another variable, and we can have here a quadratic equation. Okay, so let's say we let a be equal to x plus 1 over x. And then we'll have here a quadratic equation, a squared plus 4a plus 3 is equal to 0. Then let's factor a plus 1 and another one, a plus 3. Okay, so therefore the values of a here is -1 and -3. But we are not done here, of course, because we need to find the value of x. So let's equate this -1 and -3 to x plus 1 over x. So we have here x plus 1 over x is equal to -1, and x plus 1 over x is equal to -3. Then simplify, find the value of x. So if we cross multiply, we'll obtain -x is equal to x plus 1, and then another one, -3x is equal to x plus 1. Okay, then simplifying this, finding the value of x. On the first one, we have x is equal to -1/2. And then for the next one, we have here x equals -4. Now, if you check both the values of x here, -1/2 and -1/4, they will satisfy. Okay, they will satisfy the equation. Now, what about the application of rational function? Rational equation correction. So, I have here two examples. So, first one, in an inter-barangay basketball league, the team from Barangay Marulas has won 12 out of 25 games, a winning percentage of 48%. How many games should they win in a row to improve their win percentage to 60%? Okay, so at first, as you can see here, their standing is 12 out of 25, which is 48%. But we need to increase their winning percentage to 60%. So how many games should they win for that to obtain? Okay, so for that to happen, we need to let a variable be the number uh, of wins in a row. Let x be the wins in a row. Okay, so for that, we'll have here an equation. 12 plus x over 25 plus x is equal to 0.6, which is 60%. Okay, so we need to add, of course, to their number of wins in the league, and also the total number of games that they have played. Okay, so we add both on the numerator and the denominator, that x. Then after that, let's simplify. Okay, cross multiply. So that's 12 plus x is equal to 0.6 times 25 plus x. Quantity 25 plus x. Then simplifying that, we'll obtain 12 plus x equals 15 plus 0.6x. Then again, combining like terms. So x minus 0.6x is equal to 15 minus 12. So we'll have here 0.4x is equal to 3. Dividing both sides by 0.4, that is 7.5. So what does it mean? So therefore, Barangay Marulas needs to win 8 games in a row to raise their winning percentage to 60%. Okay, so they need to win 8 games in a row. Again, to have that winning percentage of 60%. Another example, so a social club charters a bus at a cost of $900 to take a group of members on an excursion to Cebu City. Okay, at the last minute, 5 people in the group decided not to go. Okay, it decided not to go, so this raises the transportation cost per person by $2. So how many people originally intended to take the trip? Okay, so in this case, we need to represent, of course, the given statements here. So first off, let's say let X be the number of members in the original group. Okay. And then for the statement at the last minute, 5 people in the group decided not to go. So we can subtract 5 to the number of members in original group. That will be X minus 5. Okay, so now, what about their contribution per member? Okay, what about their contribution per member? So for the original group, all we need to do is to divide that 900 to the number of members, which is 900 over X. While for the second situation wherein 5 people decided not to go, we divide 900 by X minus 5. Okay, so now let's have an equation here, a rational equation to be exact. In this case, as you can see, 900 over X minus 5 will increase their transportation costs by $2. So in short, we need to add $2 to the contribution of the original group. Okay, original number of members of that group. So which is 900 over X plus 2, and it is equal to the transportation costs when those 5 people decided not to go. Therefore, our equation now here is 900 over X plus 2 is equal to 900 over X minus 5. Okay, so we have now our rational equation. So let's try to simplify this. We can use the gram. So in this case, we have uh, LCD of X times the quantity of X minus 5. So simplifying this, we'll obtain 900 times the quantity of X minus 5 plus 2 times the quantity of X times the quantity of X minus 5 is equal to 900 times X. Then distribute 900x minus 4500 plus 2x squared minus 10x is equal to 900x. Okay, so we can simplify this. We'll obtain 2x squared minus 10x minus 4500 is equal to 0. Okay, so 900x will be eliminated. Of course, that will become 0. And then let's simplify this since they are all divisible by 2. So divide both sides by 2. We obtain x squared minus 5x minus 2250. Then after that, let's factor. Okay, let's find the values of x here. So we'll have x minus 50 and x plus 45 as our factors, which means the values of x here are 50 and negative 45. Okay, so as we recall, X is the number of members in the original group. So therefore, the value of X cannot be negative. Okay, because it's the quantity. Okay, the number of members. So we'll get the positive value of x, which is 50. Okay. So in this case, the original number of members is 50. Okay. Uh, for their excursion. Okay. So x is equal to 50.